Good afternoon, my name is Danil Arabadzhy, I'm from Ukraine. Today I'm going to talk about my work, creation of a laser 3D scanner. I will tell about its structure, principles of operation, stage of creation, advantages and prospects. Once I was just watching TV and came across a historical program. With the help of some device unknown to me at that moment, they transferred the external surfaces of building into a 3D model. It consisted of millions of points, and all I knew about the device was how it looked. After searching for information on the internet, I found that this device is called a laser 3D scanner. I love history and want to connect my love with architecture, so I decided to create my own laser 3D scanner because it's widely used in both directions. By the way, it's also used in BIM design, which gave an even greater incentive to do it. So let's understand what a laser 3D scanner is and how it works. 3D laser scanner is a device that transfers external forms of objects into a 3D model on a computer. It works thanks to the following principles. The first principle, measuring a distance to a point using a laser. A short light pulse is emitted, which is reflected from the object and returned to the receiver. As you know, speed of light is a constant, so in order to find the distance to the point, you only need to know the time it took for a beam to return. Using the formula on the screen, we find the distance. But it's not enough to know only the distance to the point, we need its coordinates. To find them, we will turn the laser range finder by azimuth and elevation angle. Knowing these two parameters and the distance to the point, we can say its coordinates in the spherical coordinate system. However, for the convenience of work, we will convert them into a Cartesian one using the formulas on the screen. More about scanning algorithm. The prototype turned by some angle step by the elevation angle, measured the distance to the point and calculated its coordinates. When he made a turn of 180 degrees by the elevation angle, a step was made by the azimuth. After that, the algorithm was repeated, only with rotation in the opposite direction by the elevation angle. I have to add that the size of the step could be changed. More detailed description on the screen. The main purpose was to stick to the budget, but due to the discovery of flaws in some components during the work and not being able to print some details on a 3D printer during the pandemic, the final price for is accurate. The development of the scanner took place in two stages, prototype and the final version. So this is a prototype, and this is how it scanned a rectangle box. There were two problems. The first one is an imprecise work of the servo drives, and the second is a design that didn't perceive symmetry. To solve the first problem, servo drives were replaced with the stepper motors. To solve the second one, the design was remade as it's shown on the screen. Due to the choosing the stepper motors, it was necessary to remake the program code and the schematic diagram adding stepper motor drivers. This is what the final version of the scanner looks like. This is how it scanned the same box. This is how it works. In the corner you can see the visualizer program while scanning the room. This is how it looks like at the moment. On the screen you can see the result of scanning part of the room. You might notice the dark circle at the bottom in the photo below. As the scanner stood at the sofa, it couldn't transfer this part to the computer because it still has a limited angle of inclination. In the end, my scanner costs 100 times cheaper than factory ones, and it scans up to 41 million points per the sphere. I think I reached the main goal.